Spacewalk from the University of Nevada, Reno. We're building 2 robots for NASA this whole year. And my name is Manuel Retana. I lead the team and I am in charge of working with code for the robot.
Hi everyone, my name is John. So I'm responsible for the CAD design and also for the fabrication for the robot.
Hi, my name is Austin Lopez. I also do a lot of the CAD design and some of the implementation of the fabrication.
Hi, I'm Nikhil Sitter. I work on a lot of the coding and the embedded electronics.
This is a 1 degree of freedom robot. But before I jump into the robot, I want to explain you what we're trying to do. You see this little cube? What NASA's trying to do is build a huge platform where you actually can mount people here. And they are going to ride this robot. What we're trying to do is to control this small scale robot and control this cube. We want to move it back and forth, so this is just a linear system. And we want to know the state of that cube at all the times as it moves.
And so we do this through all the embedded electronics. So the way it works is that we have a lot of Arduinos, or the microcontrollers, one each for the motors, the tension sensors, and the encoders. And what happens is that each Arduino gets its data, it collects all the data, and then it sends it to the master Arduino. And that Arduino then tells the cube where it is in relative to its position, velocity, and acceleration. And it's the brain of the whole system that basically tells the cube when it's too close to the edges and when and how to move across.
The hard part of this section of this robot is for everything to work together. So the sensors detect the data, they send it to the motors, and they just communicate real time at all the times, and that gets a little complicated. We can do every single thing by itself, but when you put all the sensors, the encoders, the tension sensors all together, it gets a little complicated. And we're doing this little model to prepare for the next model, which is the 6 degree of freedom robot. Now let's move. Turn it off.
What we have here is, you can see down at the bottom, we've taken the technology from the 1 degree of freedom system and we've miniaturized it, and we're going to put it in all 8 of our corners. So what we have is our motors, and when those pull, our load sensor will have strain, and then it comes up to our pulleys, which will be able to move the mass. So what this does is we'll have a mass in here that's connected to these 8 corners, and it'll be able to move in 6 degrees of freedom. So we have X, Y, and Z, and then roll pitching out, so it rotates in space. And the purpose of this is we're going to be able to, NASA wants to put astronauts in this pod for the large scope version, and then they'll be able to experience the loads and the dynamics of driving a rover on Mars.
Right now, our project is basically creating the prototype, the 6Gov. So right now we're gonna try to finish the corner. So we will have 4 corners with this configuration, which is the motor, the pulley, load sensor, and the final one is gonna have like the end effector hanging on this one. And then the important part for this 6 degree of freedom, actually the load sensor. So we want the goal for our project actually maintaining the tension for the robot. So basically when the load sensor bends, it will send us electric signal to the microprocessor, which is the Arduino, and from there we know that our robot's in tension. If there is no tension, it will tell the Arduino to send the signal to the motor to rotate, so we will keep the robot in tension. And for the 6Gov, why our prototype has wood base and on the top, because actually we want to put all the electronic we have on this one for the bottom and also for the top.